Welcome to the Explainer. Today, we are tackling one of the biggest questions out there for anyone building with AI. How do you actually know if your agent is working? And maybe more importantly, how do you make it better? We're going to break down the new playbook for observability and evaluation.
You know, this quote from Harrison Chase over at LangChain just perfectly nails the problem. See, with traditional software, the logic is all there in the code. But with an AI agent, its logic kind of emerges and changes with every single conversation. It means our old tricks, setting breakpoints, stepping through code, they just don't really work anymore. We need a new source of truth.
So, to help you get your bearings in this new world, we've put together a really clear roadmap. We're going to start with the why. Why agents are a totally new game. Then we'll give you the essential vocabulary for watching them. We'll walk through this powerful cycle of improvement, and then we'll wrap it up with a solid plan you can start using right away.
All right, let's dive right in. To really get this, we have to start with what makes an AI agent so fundamentally different from the software we've been building for decades. This is a huge shift. We're moving from debugging code to debugging reasoning itself.
So check this out. On one hand, you have traditional software. It's deterministic. You run it twice, you get the same result. The code is law. But agents, they're non-deterministic. Their behavior can totally change based on the tiniest shift in what a user says. And that's why the code is no longer the full story. The trace, the actual record of what the agent did and thought, that becomes your real source of truth.
Okay, so if we need to debug an agent's reasoning by looking at its traces, we're going to need a new language, a set of building blocks, or what we call primitives, to describe what's actually happening inside that agent's head.
The smallest, most fundamental piece is a run. Just think of this as one single action. One call to the language model, one time it uses a tool. It's the smallest atom we can look at, and it has its own inputs and outputs.
Now, when you string a bunch of these runs together, you get a trace. This shows you the entire chain of command for a single task, right from the user's first prompt all the way to the final answer. This is literally the agent's thought process, just laid out for us to see.
And finally, you have the thread. A thread just groups a bunch of traces together to capture a whole conversation. And this is so important because an agent might make a mistake on the third question because of something that happened way back on the first one. The thread gives you that full context.
So the main takeaway so far is that we need a way to see what our agent is doing, from the tiniest step to the whole conversation. But here's where it gets really powerful. These things, runs, traces, and threads, they aren't just for fixing bugs when they pop up. They are the fuel for this amazing continuous cycle of improvement that lets us systematically make our agents smarter.
And this is that core loop. It all starts with just watching, observing real-world traces from your users. Then you collect the interesting ones, especially the failures, into test datasets. With those datasets, you can start experimenting. Try a new prompt or a different model. Then, and this is the crucial part, you evaluate if your change actually made things better. And if it did, you deploy it, and the whole cycle starts over. So we've got this awesome loop, but how do we, evaluate? This is where we go from, I think this prompt is better, to I can prove this prompt is better. Let's take a closer look at how we can systematically judge an agent's performance.
Well, we can actually evaluate at different levels, just like our observability primitives. A single step eval is kind of like a unit test for reasoning. You ask, given this situation, did it pick the right tool? A full turn eval is more like an integration test, checking if the agent can finish a whole task. And then a multi-turn eval is the ultimate end-to-end test, seeing how it performs across a whole back-and-forth conversation.
So, how do we score these tests? This is pretty cool. We can actually use another LLM as a judge, basically asking one AI to grade another one. We can ask it to score things like, was the answer relevant? Did it hallucinate facts? We can even spot weird behaviors, like if an agent gets stuck in a loop calling the same tool over and over. That's a huge red flag. Okay, I know that was a lot of concepts. So let's make it real. Let's walk through a practical, real-world example to see how this whole workflow fits together to find a bug, fix it, and then prove that we actually made it better.
So let's imagine you built a personal assistant agent. A user complains that when they asked it to schedule a meeting from an email, it tried to book it for the wrong year. This is a classic, super common kind of failure. So what's step one?
We don't guess. We go find the exact trace for that user's failed request. Using our observability tools, we dive in and there it is, clear as day. The agent saw an email that just said next Thursday and for some reason inferred the year was 2023. It tried to book a meeting in the past. Okay, problem identified. Now, let's fix it. We take that failing example, we add it to a test data set, and we come up with a hypothesis. What if we just change the prompt to explicitly give the agent the current date as context? We run an experiment, pitting the old prompt against the new one, and look at those results. Correctness jumps from a pretty terrible 14% all the way up to 33%. That's a real measurable improvement. And this is just a beautiful illustration of the new workflow. It's not about just hoping your changes work. It's evaluation-driven development. You use data to find a problem, you test a solution, and you use metrics to prove your agent is getting smarter. You have to see that number go up and to the right. So the most important point here is that this isn't some theoretical thing only for massive companies. This is a practical workflow you can start putting into place today, no matter how big or small your project is. So here's your roadmap. Step 1. Before you do anything else, set up tracing. Just start logging everything. Next, just start manually looking at those traces. Get a feel for how your agent is behaving in the wild. From there, you can start building your first test data sets by flagging interesting cases, both successes and especially failures. Then you can start running offline evaluations. And eventually, you deploy and monitor with online evals to catch new problems in production. You know, when you boil it all down, what we're really doing here is building a continuous feedback loop. Deep observability gives you the raw data, and a structured evaluation process lets you turn that data into real, measurable improvements. This is how we move agent development from being an art into a data-driven science. And that leaves us with one last thing to think about. If you're building agents, those traces are so much more than just debug logs. They are the literal source code of your application's logic as it's happening. So the big question you have to ask yourself is, what is your single source of truth today?